Good evening, everyone. It is Thursday, March the 31st, 2022. My name is meteorologist Shay Gibson. I work with a private weather company called WeatherFlow Inc. We specialize in wind science, and we do have nearly 500 weather stations around the coastal U.S. and outlying territories such as Canada and Mexico. One of the things that we do is we specialize in wind readings and observations. So we have quite a mesonet or internet base of weather stations that all talk to each other, and they go out in all of our products like the shirt I'm wearing, Wind Alert. We also have Sail Flow, I Kite Surf, I Windsurf, and Fish Weather for all the folks that love to go out in the water and see the real-time data that our weather stations provide. So one thing that I want to give back tonight is I want to talk a little bit about wind science, some basic wind science. I'm going to break it down into 4 different tips just for some basics there, and we'll have a little fun talking about that. And let's go ahead and put me down in the corner. Wind 101, the basics. And let's go ahead and slide number one. Let's just talk about wind a minute. What is wind and what causes it? Well, wind is the natural movement of air across the planet's surface. It's a byproduct of the atmosphere trying to balance itself out. So whether it be cold air, warm air, storm systems, tropical cyclones, you name it, any of these systems that happen in our atmosphere or occur are trying to stabilize the atmosphere. The thing is we need that weather, we need that rain, we need the instability in the atmosphere to keep the rain coming, right? So wind is a product of that, right? So it's accelerated by the interaction between high pressure and systems and low pressure systems. We know that if you live in the northern tier of the United States, you know that the Canadian high is diving down across the Great Lakes, especially with these upper lows that come across. You know how windy it can get in those environments. Also, mountainous zones high up in elevations. Those are very windy areas when it comes ahead of cold fronts. And then also, even along the land and sea interface, along the coastlines, we see sea breezes. Now, sea breezes aren't just a breeze in off the ocean. They actually have structure and a body to them, so they're very fascinating to study. So all of these bring wind and they create wind, so there's never a dull moment in our industry when it comes down to it. They can also increase to very strong speeds where instability is occurring, such as thunderstorms, upper lows, winter storms, and tropical cyclones. We did mention that just a little bit ago about how mountainous zones ahead of cold fronts, those Canadian highs, those things tend to really ramp up wind. So it really is just the accelerated movement of air when it comes down to it. High and low pressure systems. So I definitely want to take a minute to talk about this just from basics for these. High pressure, you have to remember, we always hear about the dome of delight or the domes of high pressure that occur over various parts of the world in the United States. And really what it is like a large shield of air. When you have air that rises from low pressure, it comes out, and then high pressure is the process of cooling and condensing that air, and it falls back to the surface and spreads. So we call this divergence. When it goes away from the system, the air is moving away from the center of high pressure. It's called divergence, upper air divergence. So it's falling, cooling, condensing, falling, even warming in the summertime it can, especially when we see heat waves. But most of the time, we know this in the winter, it's very chilly air that dives down from Canada. And this is why, because the air is coming from high up where it's colder and settling down to the surface. Now, low pressure, we call this convergent flow as winds are coming in towards the center, especially if you think about a tropical cyclone with an eye. This is exactly a good example where the air comes right up through the eye, lifts vertically. It becomes warm, buoyant air that finally finds an escape hatch to get up and out of that system. Comes out, and then guess what? High pressure nearby brings it all back in play again. So you end up with what's called a secondary circulation for hurricanes, which that's how they get stronger and rapidly intensify as well. So just a little bit of basics. Now in the northern hemisphere, we see that low pressure spins counterclockwise, and then in the high pressure spins clockwise. So as these are spinning towards each other, the high pressure is coming this way, low pressure is coming this way, it creates what's called an avenue of wind or a pressure gradient. The pressure gradient that is built between these two systems accelerates the wind. So we see the stronger the high and the low, the more winds we get out of them. So that's the relationship between high and low pressure. And we see that a lot, quite a bit in the spring and even in the summertime and into the fall and winter. So it really is more so when we get into those unstable months, such as the spring and the fall. Let's go ahead and talk about tip number one, basic wind. When forecasters tell you the wind direction, such as north or whatnot, it is always the direction the wind is coming from. For example, the forecast calls for westerly winds. It's coming from the west and heading to the east. If southwest, the winds are coming from the southwest and heading towards the northeast. So you have to think about it in that manner. If someone says, hey, winds are south today. Well, they're going to be coming from the south. So that's always it. Basic tip number one. Number two, offshore versus onshore winds. Now, this is very important along the coastline, especially for fishing, sailing, and even when we get down to it, SUP, kiteboarding, anybody that's on the water. A lot of folks like to know what's going to be offshore and what's going to be onshore, especially when it comes to where to go to do your activities on the water. So we always say, if we have the little graphic down here, this is Charleston, South Carolina. These north-northeast winds are really, these are offshore because they're coming from land and heading to the sea. That's the idea, is any wind that's coming from the land and heading to the sea is called an offshore wind. Conversely, we have winds that are coming in off the ocean towards the land. That is onshore wind. Now, we do get some variants of that, side shore and also side offshore, side on, side off. There's these little variants to say like kiteboarding and other industries where you get a little bit of variant to that. But those are the basics for onshore versus offshore winds. Tip number three, cardinal directions and degrees or azimuths of wind. So when we look at cardinal directions, the cardinal directions are being north, south, east, and west. When we talk about wind, that's what we call them. Degrees of azimuths are standard mathematical units paired with circles. So if you think about a circle that is round, that's kind of where we're going with it, right? So we know that 45 degrees is going to be east, 180 degrees is going to be south, west is 270, so on and so forth. So you get to north, which is 360 or zero. Some of the older weather stations or some of the data that used to come out used to look like a really scratchy graph, and it was really hard to read for the non-user friendly types that didn't know what it was doing, but it was based on the circular degrees and really reading in that direction. So let's take a look at the blog that I wrote, see if I can find it here. Of course, there we go. All right, so we look at the cardinal directions, north, south, east, and west, right? And then you have a lot of little things going on in between, but the one thing you see here is the degrees. So 360 degrees is the same as zero, and you start there and you work your way around, or you can work your way back this way, however you want to do it. Whichever way the wind is coming from, you remember now if we have a southeast wind, right here, we know the wind is coming from the southeast at 135 or 140 degrees, however you want to call it for the southeast direction. If we go a little further down, we start getting into more directions of wind where we have northeast, southeast, southwest, and northwest winds, and those are called intercardinal or ordinal directions. And that's where you kind of get the breakdown where you have secondary intercardinal directions such as north-northeast, east-southeast, south-southeast, and so on and so forth. That's what this little drawing is right here, is showing you all the other different ones. Now, in old sailing, and even some sailors still use it. They may use like a north or a north by east, which would even be a little higher up than north northeast. It'd be in between north northeast and north. But we're not going to get into all that for this tip. I'm just telling you that there's a little bit more to it when it comes to sailing and some of the maritime environment usages for that. So going back to our PowerPoint, let's go ahead to tip number 4, knots of wind. Now, there has always been sort of a little bit of a difference in metric units versus how the Americans have done things over the years. But the original measurement of wind speed was done with knots, and a knot is the same as about 1.15078 nautical miles per hour. So that basically is miles per hour. 1 nautical mile equals 1.15078 regular miles. So basically the translation is that's what 1 knot of wind is to miles per hour. It does come from the 17th century when sailors measured the speed of their ship by using a device called a common log. That was a coil of rope with uniformly spaced knots attached to a piece of wood shaped like a slice of pie. The piece of wood was lowered from the back of the ship and allowed to float behind it. Sometimes this was done from the bow to the aft of the ship, and they would have someone drop from the bow, and they would have a lookout on the aft to time it. If it was a bigger ship, sometimes that's what they would do. If it was a smaller ship like a schooner, they would drop it off the back. But when the specified time had passed, the line was pulled in, and the number of knots on the rope between the ship and the wood were counted, and that was the speed said to be the number of knots. So now you know what knots are. And that's going to do it for this basic wind, the basic 4 tips of wind and how it's generated and how it's measured and what directions that we're talking about here. So hopefully you learned a lot tonight. Thanks a lot for watching. And I will probably be putting something together pretty soon for intermediate winds. We get into intermediate reads on that, like apparent winds and things that sailors use. But for the most part, just remember, the main keys. Wind is basically the byproduct of the atmosphere trying to balance itself. The wind directions are always what directions are coming from. Your cardinal directions being north, south, east, and west. Intercardinal directions, northeast, southeast, southwest, and northwest. And then last but not least, the knots. And everybody, thanks a lot for watching. Take care, and I'll be bringing an intermediate one soon. Thank you.